Hello Math 140 students, again this is your instructor Cindy Enrique, and we're going to pick up on section 11.3. This is all about the logarithmic functions. Logarithmic functions are inverse functions of, exponential functions are inverse functions of logarithmic functions. We can rewrite exponential functions as logarithmic functions and vice versa. The domain of the function, when it's a log, is a set of all positive numbers. That is, the argument x must be greater than 0. So a really important, or something that I would write on my note card to help myself out, is how to rewrite logs. So if I have my log, which is y is equal to log base b of x, then when I rewrite it as an exponential, it would be b to the y is equal to x. So that is how I go from log notation to exponential, or exponential to log. So we're going to keep that in mind. So for the next couple of examples, it says, hey, rewrite the equation in exponential form. So I'm going to go ahead and write what I have up above. So y is equal to log base b of x. And I can rewrite an x as an exponential as b to the y is equal to x. So let's see. It says I'm going to rewrite this so I can see that I have my base is 6. So 6 to my exponent, and the exponent is squared, is equal to 36. Okay? So let's try that again. So let's circle all of my bases. So I have my base 289, and I have my exponent. My exponent is 1/2, and it's equal to 17. Okay, so hopefully you guys are starting to see the hang of this, or the pattern. So I have my base and I have my exponent. So I have my base of 14, my exponent of -2, and it's equal to 1 over 196. Again, I have my base, so that's going to be 3. I have my exponent, which is 4. So 3 to the 4th power is equal to 81. Now what we're going to do is we're going to go backwards. Now we're going to go from an exponential into log. So again, I have my base. So there's my base. So I have log base of 64. Okay. And whatever it's equal to, that's what you're going to have. So 8 is equal to, and then you have your exponent. Your exponent is a 1/2, so it's equal to a 1/2. So 64 to the 1/2 is equal to 8. Okay, so let's try that again. So I have my base, so that's going to be 12. So I have log base 12, and here the inside of the log is going to be what it's equal to, 144. And on the opposite side, we're going to have what your exponent is. So your exponent is 2. So let's try that one more time. I have my base, so I'm going to say log, and here I have base 9, and it's equal to, well, it's equal to what my exponent is going to be. So the exponent in this case is a -2. So on the inside, I'm going to write 1 over 81. And sometimes you can write it with a parentheses or without a parentheses. It doesn't change it if you decide to write it with a parentheses. And again, for that last one, for number 8, don't forget what your base is. This is your base, and this is your exponent. So I have log, my base is 1/12, and it's equal to my exponent, which is 2. So on the inside, I have my 1 over 144. So 1/12 squared is 144. So that is going to be your quick introduction of how to go from a log to an exponential, and from an exponential to a log. Again, this is kind of your practice problems where you're going to rewrite it. So this is where you press pause on your cell phone, your listening device, whatever you're watching this on, your tablet, your computer. So go ahead and press pause and try to do problems 9 through 18, okay? So 9 through 18, press pause and work out these problems. Okay, so I have worked out these problems. I went ahead and pressed pause on these and worked them out. So hopefully this is familiar. So I rewrote all of my logs in exponential form. And for the next set of problems, I wrote all of the exponentials into log forms. So go ahead and check your answers if you want to go ahead and do that. If you have any questions, please feel free to email me and let me know, and I will try to help you out as much as I can. Okay. So now it says write the equation in exponential form and then find the unknown value. So not only are we rewriting it, but we're rewriting it and finding a value for it. So okay, so let's see. So I have 6 to the y is equal to 36. So what power does y have to be for it to be to 36? Well, let's think about this. 6 to the first power is just 6. Let's try that again. And then if I have 6 squared, 6 times 6 is equal to 36. So now I can say that my y is equal to 2. Okay. Now let's look at number 4 then. For number 4, I have 1/2 to the 4th power is equal to x. So I'm going to plug that into my calculator. So I'm going to have my 1/2 to the 4th power. Now I'm going to get my 0.0625. If I want to change it into a fraction, I could. That's 1/16. So it's 1/16 or 0.0625. So I'm going to go ahead and write that down. So I have that my x is equal to 1/16, which is the same as a 0.0625. I don't know whether or not they might ask you for a fraction or a decimal, but that's fine. Okay. So now from here, you can think of this as this is all equal to x. So you can think of it as 4 to the x power is equal to 64. So when I think about it that way, well, what power of 4 would give me 64? So if I have 4 to the 1, that's 4. 4 squared, that's 16. 4 to the 3rd power, well, if I do 4 to the 3rd power, that's equal to 64. So now I know that this is going to equal to a 3. It's equal to 3. Okay. So for number 22, 6 to what power is equal to 216? So I'm just going to plug it into my calculator. So let's see, 6 squared. No, too small. What about 6 to the 3rd power? That's 216. Perfect. So this is going to equal 3. Okay. And over here, 4 squared is equal to 16. 4 squared is equal to 16. And over here, for number 24, I have 1 over 243. So my goal is to figure out 3 to what power is equal to 1 over 243. Well, let's think about this on my calculator. If this is true, well, if I have 3, let's say, to the 2nd power, it's 9. Or 3 to the 3rd power, that's 27. 3 to the 4th power, that's 81. 3 to the 5th power is 243. So 3 to the 5th power is 243. How do I make it so it would equal to the reciprocal? Well, remember, anything to the negative exponent would give me the reciprocal of that. So if I were to plug this in, if I have, let's say, and I'm going to put this into a math equation. So I have, oops, let's clear that, 3 to the power of negative 5. I'm going to change that into a fraction. It's 1 over 243. So my answer here is going to be negative 5. Okay. And for 5 to what power gives me 125? Well, 5 times 5 is 25. Times 5 is 125. So 5 to the third power. And you're thinking 2 times 2 is equal to 4. So that's going to be squared. So 2 squared is going to equal to 4. Okay. Now for this last one, it says to graph and to state the domain and the range. So if I have log base 3 of x, well, if I have y is equal to log base 3 of x, I can rewrite that as 3 to the y is equal to x. And I can write some problems down to kind of help me. So this is going to be my exponential. So I'm going to have, let's say, some y values that I'm going to be plugging in. So 0, 2, and negative 2. So if I were to plug into my calculator, 3 to the 0 power, I get 1. Now if I were to do 3 to the second power, I get 9. And if I did 3 to the power of negative 2, I get that 0.111. So now I have some values that I can plug in. So I have 1, 0. I have 9, 2. And I have 0.11111, negative 2. So that is what my graph is going to look like for my log function. Okay, so that's the end of section 11.3. If you guys have any questions, please feel free to email me or contact the Math Success Center to get some tutoring. Thank you.